Okay, for this example problem, we're going to be simplifying this expression using reciprocal identities, quotient identities, and Pythagorean identities. And so the first thing that I'm going to do is use the reciprocal identity to try to make put everything in terms of sine and cosine. So change cosecant x to 1 over sine x, so that we have 1 over sine squared x, because it's 1 over sine x times 1 over sine x, and minus cotangent x over tangent of x. And then I'm going to change, using the quotient identities, I'm going to change cotangent and tangent into sine and cosine, into terms of sine and cosine. And tangent of x equals sine x over the cosine of x. So I can replace, I have 1 over sine squared x minus cotangent x, which is cosine x over sine x, divided by tangent of x, which is sine x over cosine of x. And so I'm going to multiply it by the reciprocal of this instead of dividing. So I have 1 over sine squared x minus cosine of x over sine x times cosine of x over sine of x. So I can change that to 1 over sine squared x minus cosine squared x over sine squared x. And I can put those over both because they have a common denominator. So I can put them both over sine squared x, and then 1 minus cosine squared x, I can use the Pythagorean identity. Cosine squared x plus sine squared x equals 1. And if I subtract cosine of x from both sides, or cosine squared x from both sides, it shows that 1 minus cosine squared x equals sine squared x. So I can change this to sine squared x over sine squared x, which equals 1. All right, I will be showing you how to simplify this expression using the Pythagorean identity and the reciprocal identity. So we're going to use one of the Pythagorean identities right here to simplify this. So cotangent squared theta plus 1 equals cosecant squared theta is our identity, and then we can change that. So we have cotangent squared theta equals cosecant squared theta minus 1, which that is equal to that, so we can change cotangent squared out for that, which means we have cotangent squared theta times tangent squared theta. And now we can use our reciprocal identity, which states that tangent of theta equals 1 over the cotangent of theta. And then we can square both sides of this equation, which this is our identity. And then we can see that tangent squared theta, we can substitute 1 over cotangent squared theta. So we have cotangent squared theta, which we can put over 1 for our own, for what you'll see, and then equals, or times 1 over cotangent squared theta, and those cancel out, which means that this equals 1.
So I'm going to be using double angle identity, so I have cosine and sine right here to simplify this equation or expression. So I'm going to start with the numerator, so I'm going to do 1 plus, and then in parentheses I'm going to do, I'm going to choose this one, so I'm going to do 2 times the cosine squared of x minus 1. So I replaced cosine of 2x with that. I'm going to put that over, and I'm going to change sine of 2x to 2 sine x cosine x. And then if you take those out of the parentheses, you're going to get 1 plus 2 cosine squared x minus 1, and then the 1's cancel out. So you have 2 cosine squared x over 2 sine x cosine x, and then the 2's will cancel out because they're just multiplied by it, and that's going to give you cosine squared x over sine x cosine x. And then this cosine x will cancel out, and 1 will from here, because that's essentially cosine x times cosine x. So you're going to get cosine x over sine x.
Good.
And then if you use the quotient identities, cosine x over sine x equals cotangent x. And that's about as simple as it gets.